This is solving systems of linear equations. Okay, please get your notes copied. It will probably be a quiz. A system of linear equations is when you have two or more linear equations on one graph. There are multiple ways that you can solve a system of linear equations. You can solve by graphing, substitution, or elimination. We're going to solve first by graphing. This is why I expect you all to know how to graph already. So I'm going to move a little fast through graphing the points because I'm expecting you to know that. Okay, so again, a system of linear equations. A system of systems of linear equations, when you have, again, two or more linear equations, is generally the one place where both of the equations intersect on one graph. What do I mean? For example, if I have two linear equations, these are two different ones, and I like to use different color markers because it helps me keep track of what's going on in my graph. So the first one will be red. This is the first equation, and then this one is going to be the second equation, green. So the first equation is y equals negative x plus 4, or y equals a negative 1x plus 4, so our slope is negative 1. And the second one is y equals 2x plus 1. To find my solution, again, a solution for a system of linear equations is the one place where they both crisscross or intersect. So, here are my equations. We copied. The first one again is y equals a negative x plus 4. And the second one is y equals y equals 2x plus 1. So I'll start with the first one. Y equals a negative x plus 4. I know that the y-intercept is at plus 4, so I'm going to go to 0, 4, which is 1, 2, 3, 4. So I'm going to start there. M is equal to a negative 1 over 1. It's going to be a negative graph because it's a negative 1x. So I'm going to fall down 1 and run to the right 1, fall 1 to the right 1, fall 1 to the right 1, and so on. If I want to go the opposite direction, it's just going to be positive 1 over a negative 1. So here and there it is. When I'm ready to graph, I'm going to come on over and I'm going to put this graph here. And when I get ready to come and do this here, I'm going to put the two arrowheads on here. Alright, so here it is. This is the graph right there for that first one. There's my line. Now I'm going to graph the second one, y equals 2x plus 1. When I do that one, what's the y-intercept at plus 1? Here it is. And my m for that one is going to be 2 over 1. So I'm going to rise up 1, 2, and then run to the left. 1, to the right, 1, and rise up 2, and run to the right again. 1, and then I can go opposite, which would be a negative 2 to the left. 2. There we are. Here it is. Now I want to graph this one as well. And I want to do this one by connecting my points. And there it is. Now, again, this is a system of equations. A system is two or more graphs or linear equations on one graph. Here they both are, the red and the green. The solution is the one point or place. Sometimes you have more than one, but in this case we have one place that they intersect. Where do they intersect? Right here, at that one point. That's my solution. What's the name of that point? That point is at 1, 2, 3, up 1, 2, 3. So the solution is going to be at 1, 3. This is my solution for my system of linear equations. It's 1, 3. It's the one point where they intersect. Let's try another system of linear equations. Here's a different system with two different linear equations. Y equals 4x plus 1, and then y equals x plus 4. Again, I like different colored markers to help me sort it better. I want to find the solution to this system of equation. The system is the one point, in this case it would be one point where they intersect or cross one another. So the first one, I want to do in red, and the second one again, I want to do in green. This is a brand new system of equations. So here I am, y equals 4x plus 1. So I'm going to solve this. What's my y-intercept at 0, 1 right here? Okay, what's my slope? Slope is going to be 4 over 1. So I'm going to rise up 1, 2, 3, 4, and run to the right one. And it's a positive slope, so I better have a positive graph. Rise up. 1, 2, 3 to go up a little further. So I'm going to stop here at this last point. If I want to go the opposite direction, it would be a -4 over -1. So starting at my y-intercept of 1, fall down 1, 2, 3, 4, run to the left 1 right here, and I'm going to put in my line. And when I do this one here, this one is going to be right there. Okay, there's my red one. Now I'm going to draw the graph, and it should have arrowheads on here because it's going to be continuous. Now I'll do the second one, y equals x plus 4. What's my y-intercept at +4? Here we are. It's going to be at 1, 2, 3, 4. And what's my slope going to be at this one? It's going to be m equals 1 over 1. So I'm going to go over 1 and up 1. Okay, and then to the left 1, down 1, to the left 1, down 1. Okay, and if I draw this one here, and this one looks like it's going to go right there, and I want that one to be green, so I'm going to change that. There it is. Okay, this means I need to extend this line a little further. So if I grab this one to see where it goes, okay, this one isn't the cutest here. It's going to intersect at that one place. It's a decimal. I'm not going to get too much in this one, but this decimal right here is going to be my solution. It looks like it's over at 1. That looks like it's over at 1 and 0.25, and then it's going to be up 1, 2, 3, 4, 5, 6, about 6.5, almost 6.5, not quite. Okay, so this will be my solution. This is the one place where the two graphs intersect. Okay? Next one. Again, the solution of a system of the equation is the one point or one place where the two graphs cross or intersect. The solution is called the solution of equations. You'll need to know that. Okay? Next one here. Next one, again, I still like, I'm going to grab and find this one here. And so here we are with two equations. Again, red and green are my colors. I have y equals 3x minus 4. For this particular one, the red one, I'm going to start at -4. 1, 2, 3, 4. Here it is down there. My slope is at 3, 1. M equals 3 over 1. So I'm going to rise up 1, 2, 3, run 1. Rise up 1, 2, 3, run 1. Okay, and then I'm going to quickly put my arrowhead in for this one. And here it is there. Alright, that's what this red one looks like. Now I'm going to grab the green one. 3x plus 1. This one is going to be a positive 1 right there. Rise up 1, 2, 3, run 1. Rise up 1, 2, 3, run 1. Okay, and I'm going to go ahead and I'm going to grab this one as well. Okay, and here it is. Like so. What do we notice about these two graphs? These two are parallel. Parallel means they run the same direction, will never ever touch. It's kind of like 7 mile and 8 mile. Because they're parallel and they run the same direction, they will never intersect or cross or overlap. How do we know these are parallel? Well, let's look at the slopes. Both of the slopes are the same, but they have different y-intercepts. Both of the slopes equal 3. This means that in this case it's going to be parallel because they have different y-intercepts. Okay? And on this one, because they're going to never touch and be parallel, this is called inconsistent. Okay? They will never ever intersect. So this one has no solution. They're parallel and they have different y-intercepts, so they will have no solution. They're never going to have one place where they're going to intersect. So no solution for this one because they're parallel, they have the same slope, and they also have different y-intercepts. So that one is no solution. Next one. Next problem here we have, okay, we're going to graph and find this one here. And I'm sure you're saying, oh, Miss Hapworth, this one is no solution as well. Well, let's look and see. Again, using the first one as my red. Y-intercept is at 1. My slope is at 2. Rise 2, run 1. Rise 2, run 1. Fall down 2 to the left 1. Here it is. Okay, so here we have our graph. And we'll put this one in here. Like so. And then here's my green one. I want to graph it as well. What is the y-intercept? At positive 1 as well. Rise 2, 1, 2, run 1. Rise 1, 2, run 1. Fall down 1, 2, run 1. Well, this one here, they look to be on top, one on top of another. This one right here, they are parallel because they have the same slope, 2. They are parallel. However, this one, they have the same y-intercept. So this one is going to be infinitely many solutions. This one has so many solutions because they lay on top of one another. There's a solution here, 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 here. There's a solution up there. There's a solution here. There's a solution down there. There are a lot of solutions because they're parallel and because they have the same y-intercept. They have many, 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 many solutions. So this one is going to be infinitely many solutions. Remember, a system of equations typically has one solution. The solution is the one place where they cross or overlap one another. So, here's the 3 types of solutions. When I have 2 different, the red and the green I was using, when they have one place where they intersect, it's going to be the solution. It's called consistent. It's consistent if the system has, they intersect in one place, at least one place. This is going to be consistent, and it's going to be independent. Okay? Consistent because there's one place that they intersect, and independent because there's one place that they intersect. So the one place is right there in the center. Here's my next type of solution that we can have. This is infinitely many solutions when it's parallel and they have the same y-intercept. It's consistent because they have at least one solution. But because they have more than one, we call that dependent. It's consistent and dependent. They have multiple, many. Consistent means I have at least one solution. Okay? And infinitely many has at least one, actually has multiple. But it's dependent because it has multiple, we call it dependent. Okay? And finally, the third type is called inconsistent. If they're never going to touch, they're parallel, but they have different y-intercept. They're parallel, but different y-intercept. That's called inconsistent. And there's going to be no solution. Okay? Make sure you know that. How do you know? Same slope, but they have different y-intercepts.